will be about Newton's first law of motion. Most of you can probably already say it. It starts an object at rest, and can you finish that? An object at rest will remain at rest. Will remain at rest. And an object in motion will remain in constant motion unless acted on by a force. And we're going to say by a net force. That means by a total of forces that is not zero, by a net force. Now this word constant, in constant motion, this word constant's important. An object at rest will remain in rest, and an object that's moving will remain moving in just the way it's moving, not accelerating, not changing. I can't spell constant, can I? C-O-N-S-T-A-N. Constant motion. The word constant is important. It means that the object is not going to change direction. It's not going to speed up or slow down. It will remain in constant motion unless acted on by a force. And if a force acts, the motion will change. So constant motion would mean non-accelerated motion. So a force that acts must cause an acceleration. If there's no net force, notice it doesn't say no force. It means no net force. If there's no net force acting on an object, that object will not accelerate. That means it'll keep on doing whatever it's doing, moving in a straight line. If it's moving, straight line, constant velocity. And if it's stationary, it'll remain stationary. If the forces that are acting on an object are balanced, we say, or the net force equals zero, then we say that the object is that the object is in equilibrium. You are probably in equilibrium right now. You are most likely sitting down, as am I. There are forces acting on you. Your chair or your bed or wherever you are, whatever you're sitting on is pushing up on you. And the Earth's gravity is pulling down on you. So there are forces acting, but you're not accelerating. And so all of these forces must add up to zero because you are in equilibrium. The first law is also called the law of inertia. And inertia is the tendency of an object to resist a change and that's not it. You don't quit there. A change in its state of motion. Inertia is one of those words that gets used outside of physics. We say we have inertia when we don't want to change. I have known people who were not real happy in their job, but they didn't want to change. And one of them said, inertia is really hard to get over. Inertia, the state that they were in at the moment. Well, that's not a physicsy inertia. That's another use of the word. In physics, when we say inertia, it's not enough to say the tendency of an object to resist a change. It's a change in what? In its state of motion. Mass is closely related to inertia. Some textbooks say that mass is a measure of inertia. And truly, something that has more mass has more inertia, has more of a tendency to resist a change in motion. It's harder to get massive things moving, and it's harder to stop massive things. Let's go back to equilibrium for a minute. Equilibrium is the situation where the sum of the forces that are acting on an object is equal to zero. Remember, we talked about net forces in the first video, and the net force is the sum, total, sum, SUM, of all of the forces acting on an object. And if the sum of the forces is zero, then we say that it's in equilibrium. If the sum of the forces is equal to zero, we also know that acceleration is equal to 0. And that tells us that the velocity, if there is any, is constant. So equilibrium is the state where F net equals 0. The net force acting on an object is equal to 0. The result of equilibrium is no acceleration, and that can be interpreted as a constant velocity, which could be a 0 velocity. Okay, so let's think back to Newton's first law. An object in motion will remain in motion. An object at rest will remain at rest unless the sum of the forces acting on it is not 0. And then if it is not 0, then the object will accelerate. If it is 0, there will be no acceleration. That doesn't say no motion. That says no change in motion. There are two types of equilibrium. There's static equilibrium, and there's dynamic equilibrium. That's dy, dynamic equilibrium. Static means no motion, and dynamic means motion. So static equilibrium is probably what you're in right now. The velocity is 0. So you're sitting in your chair, and your velocity is 0. You are not accelerating. You are in static equilibrium. But dynamic equilibrium is when the velocity is not 0. Now acceleration is 0 because it's in equilibrium, but the velocity's not 0. It's moving and not accelerating. And this is another case of equilibrium. So imagine you're driving down the road at 55 miles an hour. Now, your car is going, and so there are some forces propelling your car forward. You know, the gasoline is burning in your engine, making pistons go up and down, turning crankshafts, making your wheels turn. So there are these forces of propulsion moving your car forward. Well, if you're not accelerating, that means that the forces against your car, we would call those retarding forces, forces that would tend to make your car slow down. The retarding forces, like drag and friction, these forces must be equal and opposite to the P-U-L-S-I-O-N, whatever is propelling your car forward, the propulsion forces. If you are not accelerating, these things must be equal. The forces against your car are the same as the forces pushing it forward. Now, for some people, this doesn't make sense. Like, if those are equal, why is it moving? The nature of matter is to remain doing what it's doing. Unbalanced forces change states of motion. So the only way your car can be moving with a constant velocity, not changing direction, not changing speed, is if the forces on it are balanced. Balanced forces mean no acceleration. It doesn't mean no motion. So there is static equilibrium, like the book that is sitting on the table, and there's dynamic equilibrium, things that are moving, but moving with no acceleration. And that is the end of the Newton's first law video.